The Great Oxygen Fraud, Why Air is a Lie. The smoke wouldn't light. Firefighters stared at brush that should have flashed, and it just sulked. "Try again," the captain said. The spark danced, the tinder darkened, and the flame crawled like it had forgotten how to breathe. The meter read normal oxygen for a city street. For a fire, marginal. Zoom out. Your grandparents' air held a trace more oxygen than yours. Tiny change, easy to shrug off. But in Earth's story, oxygen doesn't slide, it snaps. When it moves, oceans flip, animals choke, fires vanish. To see why air can lie, we have to leave the sky and go underground. Roadmap of Revelations. Stable air is a comforting story. The real one has traps. We'll follow 4 threads and stitch them together. First, Earth's hidden plumbing. Subduction zones drag oxidized crust into the mantle, where redox reactions lock oxygen away. Think of it as a slow siphon, invisible at the surface, relentless below. Seismic images, mineral chemistry, and ferric to ferrous iron ratios show where oxygen's oxidizing power goes when we're not looking. Oxygen fugacity, FO2, rises in rocks even as free O2 never appears. Second, the deep time whiplash. Atmospheric oxygen has surged and crashed. The Great Oxidation, the Lamagundi Overshoot, Neoproterozoic dips, Phanerozoic spikes. The record is charcoal, chromium isotopes, sulfur mass-independent fractionations, and red beds. Each swing rewired biology, oceans, and wildfire behavior. Third, today's needle. Precise O2N2 measurements show a measurable decline. Scripps clocks roughly 19 per meg per year. Too small to make you gasp, big enough to reshape margins where fire, engines, and metabolism live. Warming seas hold less oxygen. Fossil fuels steal O2, molecule for molecule with carbon. Deoxygenating oceans and coastal dead zones map the edges. Fourth, the cascade risk. Flammability envelopes have oxygen noses. Drop below a limiting oxygen concentration and ignition fails. Aviation lives on partial pressure. Bodies ride hemoglobin curves that tilt under heat and CO2. Small shifts can become system failures in the wrong conditions. We'll trace the leak from mantle drips to cockpit warnings, from charcoal and ancient rocks to a firefighter's stubborn spark. Along the way, we'll name thresholds, not vibes, where the air's math breaks tools we depend on. To spot the leak, we start where rock breathes. The hidden siphon, Earth's mantle, quietly steals our air. Stakes first. If the solid Earth can lock oxygen away faster than life restores it, we run a permanent deficit. You won't notice on a morning run, but fires, engines, and ecosystems feel those margins long before lungs complain. The siphon hides in the engine room of plate tectonics. Action. Subduction zones are conveyor belts pointed down. Oceanic crust ages at the surface, soaks up oxidants, water, sulfate, ferric iron, and then dives. As it descends, pressure and heat squeeze fluids from that crust. Those fluids carry redox power, sulfur in mixed valence, carbon species, iron that flips between Fe2+ and Fe3+. Inside this chemical traffic, oxygen's oxidizing potential gets budgeted. Here's the quiet move. Redox reactions in the slab and the mantle wedge convert mobile oxidants into mineral bonds. Iron is the big accountant. In mantle rocks, iron divides into ferrous, Fe2+, and ferric, Fe3+. Each ferric step cages electrons and, by proxy, oxygens bite. Serpentinites and altered basalts arrive already oxidized. Slab-derived fluids shift the oxygen fugacity, FO2, of the wedge upward relative to classic buffers like phyalite, magnetite quartz. Experiments and thermodynamic models plus phase equilibria calculations show open and closed system fluids can sit log units above those buffers. The result: the mantle's redox budget inches upward while free O2 remains absent. Impact: over time, those increments matter. An oxidized mantle vents different gases. More CO2 relative to CO and H2, more SO2 relative to H2S. Change the mix and you change surface oxidant demand. Meanwhile, oxygen that once roamed as reactive power now lives inside garnet, spinel, and bridgmanite lattices at depth. It doesn't come back as O2. It returns, if at all, as water and carbonates, not breath. Case parallels sharpen the picture. Beneath North America, seismic tomography reveals dripping lithospheric roots, high-velocity blobs peeling from the base of the craton and sinking. Alongside those drips sit cold remnants of the Farallon slab, parked in the mantle transition zone. That fossil plate still warps flow, dragging oxidized material and fluids into places where peridotite is primed to take the redox hit. Mantle xenoliths show variable Fe3+ CIF-Fa ferric share, tracing regions fluids have touched. Where fluids rose, iron oxidized. Where roots dripped, dense, modified lithosphere left the party. Complication. Plumes bring volatiles up, but not oxygen gas. Hotspots tap deep reservoirs and return CO2, H2O, SO2. Those are oxidant. Carriers, not oxidants themselves. They can tilt surface budgets via weathering and burial feedbacks, but that's slow. The mantle's ledger doesn't pay back in breath, it pays back in rock chemistry and climate forcing. Meanwhile, something else was happening on a billion-year clock. Studies suggest an overall rise in mantle FO2 by about a log unit or more before the atmosphere's big oxygenation pulses. That implies deep processes, mixing oxidized reservoirs, disproportionation in a magma ocean, pushed the mantle toward higher ferric iron. Subduction kept feeding the budget. Either way, the solid Earth rearranged its own redox, then dictated gas chemistry to the sky. Stakes again, now personal. Remember that firefighter's stubborn pile? Combustion isn't a simple spark. It's a dance inside a flammability envelope defined by fuel, temperature, pressure, and oxygen concentration. Lower oxygen narrows the envelope. Industry calls the floor the limiting oxygen concentration, the point where flames won't propagate. For many hydrocarbons, that nose sits in the low teens. Ambient air is about 21% by volume. Feels safe, until you realize ignition margins collapse first, around cool starts, humidity, smoke dilution, and turbulence. Engines, furnaces, wildland fire behavior, all tuned to a balance that assumes the handrails don't move. Evidence, not metaphor. The Scripps O2 program measures atmospheric O2-N2 ratios with per meg precision. The trend is down, roughly 19 per meg per year, meaning 19 out of a million O2 molecules lost annually. That's about 0.1% over the industrial era so far. Small headline, big threshold story. Ocean warming strips oxygen solubility, stratification locks O2 out of deeper layers. Fossil fuels consume O2 stoichiometrically with carbon. Coastal dead zones spread. Argo floats profile expanding mid-water minima. These aren't rumors, they're time series. What nobody knew when we first mapped subduction was how cleanly the pieces fit. Slabs carry oxidants down. Fluids oxidize the mantle. Mantle redox shifts change volcanic exhaust. Exhaust alters surface oxidant demand and climate levers. Meanwhile, life tries to keep up. Photosynthesis minting O2, weathering burying carbon, respiration spending the balance. The siphon never yanks, it taps. Drip by drip, deep Earth chemistry leans the surface budget towards scarcity at the edges. And yet, this isn't doom, it's diagnosis. If Earth can hide oxygen in minerals, then the air stays generous only if burial and venting stay in a sweet spot. Enough organic carbon locked away, enough reduced gases scarce, enough ocean circulation to share oxygen's work. When those slip, the siphon shows itself where we live. In fires that won't start clean, in engines that stumble at altitude, in coastal seas that nap in the afternoon, glassy and breathless. Everything is about to change when we rewind through time and see oxygen, not as a line, but a whip. Whiplash world, oxygen booms and crashes in deep time. Quick gut check. If oxygen feels like a steady background hum today, that's recent bias. Rewind to a world that didn't breathe. Early Earth skies were reducing. Methane hazes, iron-laden oceans the color of tea. Then cyanobacteria started spitting out O2 as waste. No manifesto, no plan, just water split for electrons. The rock record shows how that waste scaled up and how often the system snapped. Pattern interrupt. Oxygen on Earth doesn't ramp, it cliff edges. First breadcrumb isn't blue sky, it's sulfur's weird signature. In Archean sediments, sulfur isotopes carry mass-independent fractionation, MIF. a pattern you only get when ultraviolet light hits volcanic sulfur gases in an oxygen-poor atmosphere. Those odd fingerprints show up everywhere before about 2.4 billion years ago, and then they vanish. Detrital pyrite and uraninite, minerals that crumble in oxygen, stop showing in river gravels. Red beds, sandstones stained with iron oxides, spread across continents. Translation: the Great Oxidation Event. O2 didn't drift upward, it crossed a threshold where it could persist. That's a switch, not a slider. Hold that thread. Carbon scribbles louder. The Lomagundi-Getuli excursion. Carbonate rock's worldwide record, the 13C, pushed far positive for tens of millions of years. The usual reading is a burial boom. Organic carbon gets locked away, leaving the dissolved pool heavier in 13C. By stoichiometry, that free burial frees oxygen. If that reading holds, Earth overshot into a breathier state. Brief oxidant windfall. Pattern interrupt. Every windfall has a clawback. Multiple proxies, chromium isotopes in paleosols losing oxidized signatures. The reappearance of iron formations in some basins. Trace metals behaving like low oxygen seas. Imply an O2 retreat. The crash details are debated, but the silhouette is clear. Atmospheric and oceanic oxygen aren't ratchets. They can slip. Zoom on stakes, even when life is microbial. Oxygen is fuel and poison. Too little, complex. Metabolism starve. Too much, cells burn. Evolution built buffers, antioxidant enzymes, membranes that mop up reactive oxygen species, and learned to live at shifting floors. When O2 rose regionally, metabolisms bloomed across new redox gradients. When it dipped, those experiments paused or vanished. Quick audience check. If microbes rode the roller coaster, why would our hardware be exempt? Fast forward to the Neoproterozoic, 800 to 540 million years ago. Snowball Earth glaciations bookend flickers in redox proxies. Chromium isotopes, sulfur cycles, and iron speciation paint a patchwork. Oxygenated surface waters over anoxic depths. In those windows, animals appear. Biomarkers hint at sponges. Burrows and tracks scratch across seafloor mud. Then radiations stall and restart, suggesting the oxygen floor wasn't steady. Pattern interrupt. Imagine a power grid flickering while you're trying to invent electricity. That's early animal evolution under a twitchy O2 sky. Land plants change the rules. Devonian to Carboniferous swamps pump O2 and bury organic carbon. Atmospheric oxygen likely climbs above modern levels. Some models suggest 25 to 30% by volume. The charcoal record spikes because fire loves oxidant. Ignition thresholds drop. Fires proliferate. Insects grow larger. Dragonflies with hawk-sized wings exploit dense air and maybe high O2. But fire is a thermostat. Too much oxygen, the world burns too easily. Frequent fires prune forests and curb O2 production. Feedbacks fight extremes. Audience nudge. High O2 Earth literally tuned itself with fire. When oxygen sagged, the blows were brutal. Several mass extinctions track marine anoxia and euxinia, waters devoid of O2 and laced with hydrogen sulfide. The end Permian Great Dying bears chemical fingerprints of widespread oxygen loss. Uranium and molybdenum isotopes shift. Black shales stack. Biomarkers of anoxygenic phototrophs appear in surface waters. Volcanism drove CO2 and heat. Stratification thickened. Oxygen couldn't penetrate. The biosphere didn't just lose species, it lost the chemistry that fed them. Pattern interrupt. Flip your aquarium pump off for a week, now scale to an ocean. Wildfire writes the oxygen diary in bold. There's a lower bound below which plants won't ignite and an upper zone where flames run wild. The Devonian Carboniferous seam is loaded with charcoal, a planet flirting with high O2. Later, charcoal wanes with O2. Fire breathes with oxygen and leaves soot as receipts. Quick aside. This is why firefighters and paleogeochemists secretly read the same ledger. Meanwhile, the solid Earth nudges the controls. Mantle redox likely rose by roughly a log unit across early time. That doesn't mean free O2 underground. It means more ferric iron and minerals, which changes volcanic exhaust, tilting toward CO2 and SO2 rather than their reduced cousins. Swap the gas mix at the vents, and you change how easily the atmosphere can hold O2. Tectonics shuffle continents, altering weathering and nutrient delivery that prime the biological pump. Microbes invent new metabolisms, nitrification, denitrification, sulfate reduction, that move oxidants in and out of storage like accountants with 1,000 ledgers. Pattern interrupt. The atmosphere runs on geology's tax code. Here's the hinge back to now. We live near a summit, about 21% O2 by volume, held by feedbacks that never sleep. The archive refuses to promise stability. When burial outpaces respiration, oxygen climbs. When warming, nutrient pulses or reduced gas vents tip the ledger, O2 can stall or fall. Past swings didn't ask permission. They exploited thresholds and multipliers and then settled into new modes. Audience check. Do you still feel confident that 21% is a guarantee? So when a spark sulks in modern tinder, it isn't prophecy, it's a reminder. Oxygen is not a backdrop, it's a player with a fast temper. The rock record's lesson is blunt. Don't mistake a long plateau for a lock. The air can move fast when thresholds line up. And when it does, it drags oceans, fire, and living things with it, just as it has again and again. And here's the quietly freaky part. This threshold behavior looks a lot like the optimization logic we use in machines. Systems finalize detail where conditions demand it and go coarse everywhere else. Keep that lens handy. It's about to become a map, not a metaphor. Today's needle, are we losing oxygen now? Start with the meter, not the mood. On wind-scrubbed headlands and remote islands, flasks fill with clean marine air. Back in the lab, analysts compare the O2-N2 ratio against mid-198's reference tanks with per meg precision. Changes of a few dozen molecules per million. The line slopes down. About 19 per meg per year. Since the late 198s, that's roughly 0.1% of the atmosphere's oxygen. Too small to feel in your lungs at sea level. Big enough to matter where systems run on margins. What's spending it? Two culprits, one loud, one quiet. Combustion first. Burn carbon and hydrogen, and you bind oxygen into CO2 and H2O. The planetary ledger is explicit. Fossil fuel use pulls O2 down, molecule for molecule with carbon oxidized. The quiet thief is heat. Warmer surface waters hold less dissolved oxygen. Solubility drops as temperature rises. Stratification pins what oxygen remains in thin sunlit layers, starving depths. Argo floats don't editorialize. They profile expanding oxygen minimum zones. Coastal sensors catch seasonal dead zones growing where nutrients and heat stack the deck. Now, a straight clarification. Global air still holds about 21% oxygen by volume. That's well above hypoxia thresholds at sea level. So why care? Because civilization runs on edges. Flammability envelopes tighten as oxygen drops or as CO2 and water vapor dilute air. A flame that used to catch cleanly in cooler, drier conditions now starts reluctantly, soots more, quits sooner. Wildland fires flip towards smolder in warm, smoky boundary layers. Smolder is harder to kill and dirtier to breathe. Firefighters feel that shift long before city monitors do. Engines notice too. Turbines and pistons don't care about percent, they care about partial pressure. At altitude, air thins. Designers expect that. Add subtle background O2 decline and moisture, warmer intake air, and relight envelopes narrow. Ignition kernels cool faster, lean blowout comes earlier. Certification standards and pilot training account for the worst corners, but corners move. Maintenance logs quietly record sluggish relight, exactly the kind of micro signal that tells you margins have narrowed. Hemoglobin's curve is steep across the middle. Small changes in alveolar oxygen, CO2, and temperature nudge saturation more than intuition expects. Bodies are instruments tuned to gradients. In a crowded, warm, poorly ventilated room, elevated CO2 and heat shift the curve. Effective oxygen delivery dips, even if air composition is nominal. Athletes, NICU clinicians, and high-altitude workers manage this every day with pacing, titration, acclimatization. Cities meet it during heat waves and smoke. ERs see more cardiac and respiratory stress, not because the global 21% vanished, but because local delivery faltered. Signal versus noise matters. The Scripps O2 program's trend is robust, cross-checked against CO2 inventories, and mirrored by independent stations. A 12-year continuous series from the UK finds about -24 per meg per year for O2, consistent with the global picture. NOAA-backed analyses outline upper bounds on future O2 loss. that still don't threaten direct respiration at sea level, but they don't promise comfort at edges. Aviation tolerances, flammability limits, coastal hypoxia, human performance in heat and stale air. The ocean's role is the hinge. Warming reduces solubility. Circulation controls delivery. Biology spends what physics allows. There's a human blind spot that makes slow danger easy to miss. We calibrate to now. You won't walk outside and say, O2 is 0.1% lower than when I was born. But the systems that turn air into work do report it in sootier starts, in narrower relight maps, in fish pinned into thinning habitable bands. Buildings hide it with smart fans, jet controls mask it with software, hospitals buffer it with oxygen plants. Resilience is real. It also acts like camouflage. So where are the thresholds? For many hydrocarbons, the limiting oxygen concentration sits in the low teens at standard pressure, but temperature, pressure, humidity, and diluents move it. In aviation, relight requirements are codified. Aircraft must prove flame stability across worst-case altitude, speed, and temperature. Warmer, wetter backgrounds thin the cushion. At sea, oxygen minimum zones expand laterally and upward, nudging fisheries toward coasts and storms. On land, cognitive performance dips in poorly ventilated schools track CO2 and heat, stand-ins for oxygen delivery stress. None of this is apocalypse. It's a baseline shift with consequences. The fix list isn't exotic. Cut combustion so the oxygen bill shrinks. Cool and mix waters so the ocean can share its oxygen. Design engines, buildings, and protocols for thinner margins. Make oxygen supply in hospitals and cockpits boringly reliable. The meter keeps falling, molecule by molecule. The right response is to pay attention where edges matter. The match, the turbine, the ward, and move the edges back. Fire's secret contract, the oxygen combustion economy. Civilization runs on tamed flames. Boilers, turbines, furnaces, engines, kilns. But fire isn't a switch. It's a contract with oxygen that has clauses and penalties. Break the terms. Drop the oxygen fraction, add diluents like CO2 and water vapor, lower intake temperature or pressure, and the flame doesn't rage. It hesitates, soots, or quits. Ignition is clause 1. A spark must seed a radical pool. Chain branching reactions involving H, O, and ODEs that outruns heat loss. That balance defines the limiting oxygen concentration, the floor below which a flame won't propagate for a given fuel, pressure, and temperature. In clean, dry air at sea level, many hydrocarbon air systems burn down into the low teens oxygen by volume. Add humidity, smoke particles, or CO2, and that nose shifts upward. Minimum ignition energy rises. Lean blowout arrives earlier. Laminar flame speed falls, and turbulent flames, our workhorse, lose their cushion. Clause 2 is stability. Burner designers fight a tug of war. Too slow a flame, and it lifts off and blows out. Too fast relative to flow, and it flashes back, damaging hardware. Lower effective oxygen trims, laminar flame speed, and widens the range of flow conditions that end in liftoff. Industrial burners compensate with swirlers to anchor the flame, pilot fuels to ensure hot kernels, staged air to keep radicals fed. Those work until ambient conditions nudge every margin the wrong way. Warmer, moister intake air, a tick leaner oxidant, slightly cooler preheat, and a start that used to be routine becomes temperamental. Clause 3 is completeness. Slow radical chemistry means more incomplete combustion. Carbon monoxide, unburned hydrocarbons, aldehydes, soot. You didn't just lose heat output, you gained pollutants and fouling. Soot loads heat exchangers and turbine vanes, pushing maintenance forward. Co-trip monitors that never blinked now catch tired starts. Plants respond by richening mixtures, upping preheat, or lengthening igniter duty cycles. Each fix a quiet admission that the contract term shifted. Industry knows these terms in reverse because it uses them for safety. Inerting systems, flood tanks, and vessels with nitrogen to push headspace below a tested limiting oxygen concentration. Jetliners carry on board inert gas generation to keep fuel tank ullage lean enough that a spark becomes harmless. Those lock values depend on pressure and temperature. Winter ramps aren't summer ramps, takeoff isn't cruise, and margins are sized to worst cases. A background slide in oxygen availability or added diluents from hotter, wetter air doesn't nullify the design. It narrows the cushion. Engines write a stricter addendum. A piston engine must carry a turbulent flame across a cylinder in milliseconds. Slower flame speeds from lower effective oxygen or higher diluents shrink the stable map. More misfires at lean, more knock risk at rich. Designers fight back with boost, tumble, multi-spark, and stratified charge. But the fundamentals remain. Partial pressure pays the bill. In gas turbines, combustors must light and stay lit across altitude, speed, and temperature. Certification demands relight across cold, thin air. Operators practice for flameouts. Warmer, moister ambient, and a barely leaner background, O2, tilt the odds. Ignition kernels run cooler. Relight times lengthen. Maintenance notes hesitant light at conditions that never used to raise eyebrows. Wildfire carries the same contract into the open. Oxygen-rich air lowers ignition thresholds. Oxygen-lean or diluent-heavy air nudges behavior toward smolder. Smolder creeps, resists water, and pumps particulates. Crews hate it because it steals clean edges and lungs. The charcoal record is the long-term ledger. Fires proliferate when oxygen is high and retreat when it's low. Today's shift is subtle. Warmer, moister, smokier boundary layers in some regimes, plus micro drops in effective oxidant mean more stubborn starts in certain fuels and conditions, and nastier smolder once they go. Human spaces aren't exempt. Kitchens and boilers feel lazy flames on humid, high ozone afternoons. Pre-mixed burners lift and spit. Crematoria and kilns tweak air fuel to keep color and phase on spec when intake air carries more water. Hospitals test backup generators under load during heat waves because warm, dilute intake air makes first-turn success less guaranteed. Each adaptation is small. Together, they map the contract. None of this claims ambient oxygen has fallen anywhere near levels that threaten breathing at sea level. Measurements from programs like Scripps put the decline near 19 per meg per year, about 0.1% over the modern record. But combustion lives on thresholds, not averages. The same fractional slide, plus heat and humidity, raises minimum ignition energy, lowers flame speed, and narrows stability windows. In systems built to edges, turbines at altitude, emergency starts, inerting set points trimmed to weight and cost, that matters. The path forward isn't mystical. Trim the oxygen bill by retiring unnecessary flames. Electrify end uses where practical. Where combustion stays, design for thinner margins. Better igniters, flexible staging, real-time controls that sense humidity and oxygen and adjust. Keep inerting honest to tested LOCs across temperatures and pressures. Train for relight and verify under the new corners, not the old ones. The contract hasn't been canceled, it's just charging late fees. Thin air, aviation, engines, and edge of failure physics. Up where oxygen is thin, machines and people live by numbers, not hope. Engines don't see 21%. They see partial pressure, temperature, humidity, and whether a flame kernel can outrun cooling inside a rushing tube of air. That's the edge of failure world, and tiny drifts show up early. A jet engine is a choreography of margins. Compressors squeeze thin air. Injectors atomize fuel. The combustor lights and must stay lit while a turbine skims energy to keep the cycle spinning. At sea level, there's padding. At 35,000 feet, oxygen per gulp is a fraction of home. That's expected and certified. Relight envelopes are proven across altitude, speed, and temperature. But add warmer, moister intake air and a subtle background O2 decline, and those envelopes narrow. Minimum ignition energy rises. Kernels cool quicker. Lean blowout edges closer. The checklists haven't changed, the corners have. Sensors don't report vibes, they report partial pressures and flows. Military and commercial jets with onboard oxygen generation systems blend and concentrate O2 to keep pilots within safe saturation ranges despite cabin altitude. NASA's pilot breathing assessments map how mask pressure, O2 fraction, and CO2 washout interact under workload. The lesson is blunt. Physiology sits on the same math as combustors. A small shift in alveolar oxygen or CO2 changes performance on steep parts of the hemoglobin curve. Long-haul crews feel it as fatigue, a miskeyed waypoint, a sluggish fix caught by CRM before it becomes a story. Compressors hate surprises. Swallow a gust, a sheet of rain, or a distorted inflow in clear air turbulence, and stall margins shrink. Combine that with thin air, higher humidity, and slightly reduced oxidant availability, and a transient that once recovered on a single spark now takes two. Certification demands relight under icy thin conditions. The physics is rehearsed. But real weather is trending warmer, wetter in many routes, and the safety cushion is thinner there. Maintenance logs capture it best. Hesitant light, longer spool, notes that read boring and mean everything. Piston engines live closer to the flame. A turbulent front must cross a cylinder in milliseconds. Lower effective oxygen and higher diluents slow flame speed and tighten the stable map. Misfires lean side, knock rich side, pilots lean mixtures by EGT and sound. On hot, humid days, the same setting runs rough sooner. Smoke season adds CO and particulates, displacing clean intake and cooling kernels. The fix is simple. Adjust earlier, accept performance hits, but the pattern is new enough to be noticed. Cabins are engineered kindness. Pressurization holds the cabin at a fraction of outside altitude to prevent hypoxia and decompression sickness. None of that fails because global O2 has slipped by 1% since the late 198s. Oxygen masks drop if needed, and systems are sized to cover escape profiles. But effective delivery still depends on partial pressure, CO2, and temperature. Warm cabins with elevated CO2 from packed flights nudge physiology down the same slope as a combustor kernel. Harder to start, easier to quit. Training and procedures absorb the drift. It shows up as hydration strategies, rest cycles, and subtle changes in how crews manage workload on red eyes. Fuel chemistry adds its own fine print. Sustainable aviation fuels must match energy density and ignition behavior across conditions. Standards demand that relight and stability meet spec at altitude and low pressure. Warmer, wetter backgrounds don't rewrite those specs. They shave the margin. A blend that lights crisply in a cold, dry test might hesitate on a tropical night at cruise. That's why airworthiness standards build in worst-case corners, and why test matrices keep expanding to reflect the air we actually fly through. Regulations quietly encode the stakes. Transport standards require fire protection across systems and reliable ignition behavior under defined extremes. The point isn't drama. It's designing so that tiny atmospheric drifts never become incidents. Still, the edge isn't abstract. An auxiliary power unit that balks after a warm soak on the ramp, a cross-bleed start that needs a second attempt, a descent through smoke that leaves passengers lightheaded. Each is a breadcrumb pointing to the same constraint. Less effective oxidant, more often. Meanwhile, oceanic routes see the knock-on effect from below. Warming, stratified waters ventilate less oxygen, compressing marine life into thinner bands. Jets that skirt those bands fly in air masses shaped by the same heat. Clear air turbulence patterns shift with changing gradients. Distorted inflow events have subtly different statistics. The engines still start, the flights still land, but the system is earning its safety the hard way. Clarity matters. The Scripps O2 trend, around 19 per meg per year decline in O2N2, doesn't endanger breathing at sea, level. Aviation authorities don't flag ambient O2 as a causal factor in accidents. What it does, alongside heat and humidity, is trim margins that were never lavish. That's why operators test relight in hotter, wetter regimes, why mask systems are audited against real workloads, why maintenance squawks about lazy lights get read twice. The fixes aren't exotic. Update relight maps with live humidity and temperature inputs. Validate sustainable fuel ignition behavior at the real corners. Keep pilot oxygen systems transparent and conservative. Practice flameout drills in the new atmospheres, not the old ones. The sky still carries us. It's just charging interest on every assumption. Bios redline bodies, brains, and the oxygen tax. Start with stakes you can feel. Your brain is 2% of your mass and takes around 20% of your oxygen. Miss a sliver in delivery, and it doesn't scream. It blurs. Names pause, choices slow. In hypobaric chamber studies and long-haul flights, healthy adults lose attention and working memory with modest dips in alveolar oxygen, especially when CO2 and heat rise together. Hemoglobin's S-curve explains it. The middle is steep. Small shifts in partial pressure, temperature, or CO2 move saturation more than intuition allows. Action. Researchers walk volunteers up mountains or simulate altitude. EEGs show changed power spectra. Reaction times lengthen. Sleep fragments with apneas and arousals. At cabin altitudes of 6,000 to 8,000 feet, many sit with blood oxygen saturation in the low 90s without noticing. Add dehydration, circadian slump, or smoke, and the baseline phrase. VO2 max declines predictably with altitude. Athletes train around it, workers pace around it. Meanwhile, urban microclimates recreate a softer version at sea level. Heat, humidity, elevated indoor CO2, and pollution dilute effective oxygen and shove physiology down the same slope. Micro-stories make it real. A nurse on a smoke day hustles between rooms. Patients need higher oxygen flows for the same saturations. Charting lags. Her watch logs the day's highest heart rate. A teacher cracks a window in a warm classroom. CO2 creeps past 1,500 ppm. Kids get foggy, not defiant. In a high-rise gym after a heat wave, the same workout feels heavier. Sleep that night is restless. Nothing catastrophic, everything nudged. Mechanism matters. Oxygen transport is a gradient game. Ambient air to alveoli, alveoli to blood, blood to mitochondria. Raise CO2 and temperature, and the dissociation curve shifts right, the Bohr effect, making hemoglobin unload oxygen more readily in tissues, but bind less in lungs at a given partial pressure. That helps in muscle, hurts in marginal lungs. Add smoke's carbon monoxide, which binds hemoglobin 200 times more tightly than oxygen, and capacity shrinks. Wildfire seasons stitch that chemistry into daily life. ERs see more cardiac and respiratory events, not because oxygen vanished, but because delivery faltered. Infants and elders live closer to the edge. Neonates and NICUs rely on tight oxygen windows. Too little steals development, too much scars eyes and lungs. Pulse oximeters aren't oracles, skin tone, temperature, and motion bias readings, so clinicians titrate with alarms and experience. Elderly patients with heart failure or COPD ride narrow margins. A hot, stale room turns a stable afternoon into a wobble. Hospitals prepare with redundant oxygen plants and drills because summer outages now arrive with smoke. Cognition tags along. Studies link elevated indoor CO2, often just a proxy for stale, warm air, to measurable drops in decision-making. That isn't CO2 narcotizing you at 1,200 ppm. It's the package deal. Less effective oxygen delivery, higher thermal load, more distraction. The fix is ventilation and heat management, not pep talks. Offices that dial in fresh air see fewer headaches and better scores. Schools that show CO2 on the wall give teachers a knob they can actually turn. At altitude, pilots live the lesson. NASA breathing assessments show how mask pressure, O2 fraction, and CO2 washout interact under workload. A lazy seal or a valve lag doesn't sink a flight. It trims cognitive margin. That's why checklists multiply and crews cross-monitor. Physiology shares math with combustors. Kernels that fail to light and thoughts that fail to land often have the same culprit: thin gradients and too much heat. Meanwhile, sport and labor adapt on their own. Marathons shift start times earlier to dodge heat and pollution. Construction sites on upper floors add breaks because mistakes spike after lunch in July. Warehouse workers pace forklift runs in smoke. These aren't vibes, they're accommodations to physics. You can bully a match, you can't bully hemoglobin. Impact. The oxygen tax isn't a monster bill, it's a fee on everything difficult. Heat waves and smoke seasons raise it, stale buildings raise it, long-haul nights raise it. It shows up as slower thoughts, shortened tempers, restless sleep, and small errors. Multiply that across classrooms, cockpits, wards, kitchens, and job sites, and you've mapped a quiet economic drag, meaning it's design, not doom. Make gradients easy again. Cool spaces so lungs win the Bohr trade. Ventilate and filter so indoor CO2 stays low and particulates stay out. Put CO2/temperature displays where decisions happen. Treat hospital oxygen as infrastructure. On-site PSA plants, backup power, rehearse protocols. Plan cities to shave heat. Trees, shade, water where it counts. Athletes and workers already periodize. Buildings and schedules should too. You can't feel 0.1% global O2 slide. You can feel the room. The oxygen tax is paid locally, in attention, stamina, and sleep. Lower the bill, and brains brighten. Keep pretending it's fine, and the day keeps getting heavier. The interface trick, why we don't notice the slow suffocation. Stakes first. If oxygen quietly slips while heat, humidity, and CO2 rise, why don't we feel it? Because perception isn't a lab instrument. It's an interface tuned to keep us alive in the moment, not to measure slopes across decades. That interface screams at smoke and sharp pain. It shrugs at small gradients. The result is a mismatch. Our meters say the line is falling. Our bodies keep saying fine. Psychophysics has a clean name for this: diminishing sensitivity. We notice differences, not absolutes, and we adapt fast. Walk into a stuffy room. A minute later, the smell fades. The same recalibration hides slow harm in air. A fractional dip in effective oxygen delivery piggybacks on warmth and CO2. The only signal we get is a soft yawn, a foggier head, a shallow night. Not alarms, shrugs. What makes it worse is how instruments, our prosthetic senses, also have blind spots. Pulse oximeters drift with skin tone, perfusion, and motion. Hyper-accurate O2N2 analyzers read per meg trends no one can intuit. Building sensors sample a duct and call it a floor. Cockpit probes lag during rapid climbs. Each device extends our sight and then injects uncertainty. Humans do what we always do. Pick the optimistic number and move on. Add normalcy bias. If last summer's generator started on the second try, this summer's third isn't a trend, it's quirky. If a crossbleed start takes a beat longer on a humid night, it's just weather. If a classroom drifts to 1,500 ppm CO2 after lunch and kids get foggy, it's post-meal slump. We prefer patch notes to rule changes. That habit saves attention during crises. It hides slopes that matter. There's a deeper lens from cognitive science that fits the pattern. Donald Hoffman's interface theory argues perception is a dashboard, not a window. Our senses present icons we can use: safe breath, bright room, tired, while hiding the code. Whether or not you buy his whole framework, it explains the blind spot. The oxygen icon lights green until, locally, it doesn't. The detailed log, partial pressures, radical chemistry, flame speeds, never renders by default. Microstories anchor the gap. A teacher tapes a cheap CO2 meter on the wall. It reads 1,800 ppm at 2 p.m. She cracks a window, the number drops, kids perk up. She didn't feel a suffocation. She saw a gauge. A warehouse foreman moves brakes earlier in July because mistakes spike after noon. No one blames oxygen. Everyone notices fewer accidents. A pilot logs hesitant relight on a hot, wet cruise night. Maintenance tweaks. The note disappears. The slope persists. Technology both saves and camouflages. Smart buildings boost ventilation in response to CO2. Aircraft control laws widen relight maps. Hospitals install on-site oxygen plants and layered backup power. Each patch restores function and teaches us nothing changed. Until a heat wave and smoke strain all the patches at once and we meet the raw edges. Smolder that won't quit. Generators that balk. Wards that run closer to the line. So how do you make a gradient visible? Externalize it. Put the slope on a screen people actually use. In classrooms, show CO2 and temperature where the teacher stands, with simple colors tied to actions. In hospitals, dashboard oxygen plant status, backup runtime, and ward-level saturation alerts. In cockpits, integrate real-time humidity, temperature, and O2 trend into relight guidance, not just as fine print in a manual. On factory floors, pair burner control with intake humidity and O2 corrections. Then surface start reliability as a number operators watch. Culture helps. Reward the boring note, the hesitant light, the needed richer trim. The kids perked up at 900 ppm as signal, not noise. Train teams to treat quirky as a trend candidate. Give maintenance and teachers the authority to act on gauges without 6 signatures. Build expectations around edges that really move: heat, humidity, CO2, and the tiny O2 drift that sharpens all 3. One more twist. Don't rely on averages. A citywide 21% means nothing to a smoggy classroom at 3 p.m., a combustor kernel at 35,000 feet, or a NICU during a brownout. Design monitoring at the scale where work happens, room, burner, ward, engine, and let local decisions move quickly. The payoff isn't dramatic. It's the return of ease. Fewer sooty starts, cleaner relights, brighter afternoons in schools, nights of steadier sleep. You still won't feel a 0.1% global O2 slide. You'll feel a room that stays clear, a flame that catches, a checklist that moves. That's the only kind of proof our interface trusts. Icons that flip when it matters, and knobs that make them flip back. Rendering the air, simulation logic meets atmospheric shortcuts. We've been treating air like a budget with thresholds. Now switch lenses. Think like a renderer. In games and VR, the machine doesn't draw every brick, shadow, and raindrop at full fidelity. It renders the fovea, the part you're looking at, in high detail and fakes the rest. It's not lying, it's optimizing. Physics keeps arriving at the same solution. Finalize detail where it's demanded, conserve effort everywhere else. Quantum experiments hint at this logic. An electron's position isn't fixed until you ask a detector for it. In VR, a wet street doesn't get real-time reflections until your gaze lands. Different domains, same rule. Compute only where attention or interaction makes it necessary. That doesn't prove we live in code. It frames how complex systems stay coherent without wasting energy. Aviation and buildings run this way. Pilots don't perceive the atmosphere. Instruments sample partial pressure, CO2, humidity, and O2 at a probe, then the system extrapolates. A cockpit oxygen system blends flows to hit target saturation. The rest of the cabin inherits the setting. In offices, a single duct sensor reports CO2, and fans surge for a whole floor. Headline numbers look calm. Back corners can stew in stale air. Detail is granted at sensors. Everything else is assumed. Fire behaves like a renderer too. A forest has no flame speed until ignition stitches a reaction front across fuel and air. Chemistry resolves at the edge, calculates fast, moves on. Lower effective oxygen, higher humidity, and smoke dilution make that render loop stutter. The kernel can't outrun cooling. So the scene drops to smolder, the low frame rate mode of combustion, dirty, persistent, hard to extinguish. Engines already exploit shortcuts. Gas turbines test relight at a handful of representative corners. Cold, thin, dry, warm, moist, mid-altitude, and interpolate the envelope. They don't prove every permutation of heat, humidity, and background O2. Controls then adapt in real time to sense conditions. It's foveated certification plus foveated operation. Works beautifully until a rare stack of warm, wet intake, subtle O2 decline, and a transient inflow distortion pushes outside the trained space. Then you see hesitant light in the log. The model met a tile that wasn't fully rendered. Ocean monitoring is the same. Argo floats dive on grid lines, turning vast volumes into heat and oxygen maps. The ocean between tracks is filled by physics and statistics. Good enough to catch deoxygenation. Thin enough that a dead zone can bloom between lines and surprise a fishery. We're not failing, we're optimizing. But when budgets tighten, heat climbs, oxygen slips, those shortcuts surface as glitches. Fish kills after a heat wave, brownouts with smoke, engines that balk on a tropical night. If you want to make this lens useful, spend precision where failure hurts. In buildings, don't hide air quality in a duct. Put CO2, temperature, and humidity where people decide. Teacher desk, ICU doors, and tie colors to actions. Open, purge, slow the room. Tie controls to multiple sensors per zone, so a single stale corner can't ruin an afternoon. In refineries and warehouses, couple burner controls to live intake O2 and humidity, then show start reliability as a number. It's the flame's frame rate. Operators will protect it if they can see it. In aviation, feed real-time humidity and temperature, plus O2N2 trend into relight guidance and health monitoring, not just into engineering reports. Validate sustainable fuel blends at the real corners, hot, wet, mid-altitude, so the fovea matches the flight. Keep pilot oxygen systems conservative and transparent. Treat CO2 washout like a primary, not trivia. If the corners shift, update the map and train there. Cities need the same discipline. Heat islands kill gradients. Shade, trees, and cool roofs aren't landscaping. They're oxygen delivery multipliers. Public dashboards for river oxygen and dead zone risk let fleets and outfalls adjust before fish get pinned. Schools that post CO2 and temperature change behavior. Maintenance crews fix dampers when a red bar goes sticky. You don't convince people with per meg plots. You give them a knob and a gauge. There's a caution baked in. Rendering logic fails when you pretend one gaze covers the world. A single buoy, one cockpit probe, one duct sensor. All cheap icons for a messy field. Redundancy isn't waste, it's resolution where it counts. Place sensors at edges, burners, wards, classrooms, cockpits, river mouths, and let local loops act fast. Blur is fine where failure doesn't matter. This lens doesn't make air a simulation. It explains why we miss slow change and how to catch it. Oxygen decline is small. Heat, humidity, and CO2 are big. Together they starve the render loop that keeps flames clean, flights crisp, and brains bright. Put detail where the work is, and the world stops stuttering at the edges. The 4 levers: oceans, forests, rocks, and fire. We've traced where oxygen slips and how edges thin. Now comes the part we can actually move. 4 levers matter because they set the budget and the delivery. Oceans, forests, rocks, and fire. None are slogans. All are plumbing. Oceans first. They're the largest store of breathable potential you'll never see. Cold water absorbs more oxygen. Mixing shares it downward. Warm the surface and the lid tightens. Stratification grows. Oxygen stays trapped above the thermocline, while depths go hungry. Argo floats show this cleanly, expanding oxygen minimum zones, seasonally hypoxic shelves. Biology rides that hinge. Phytoplankton in the sunlit layer mint O2 and ship carbon downward as particles. If a fraction of that organic carbon escapes remineralization and gets buried, it credits the atmospheric ledger. If not, microbes and chemistry spend the oxygen in the dark. The lever is delivery. Cut nutrient surges that fuel oxygen debt. Buffer strips, cover crops, wetland reconnection. These keep nitrogen out of rivers and shave the summer hypoxia that kills bays. City sewers matter too. Separate stormwater from wastewater so heat waves don't turn into oxygen crashes after every downpour. Offshore, precision counts. Talk of iron additions floats around, but the science says treat the ocean like a patient. Monitor, proceed cautiously, and prioritize mixing and runoff control that work within seasons. Forests are the bodyguard, not the bank. They don't mint net oxygen over centuries. Their real power is cooling and damping. A standing forest shades soil, moistens air, seeds clouds, and trims fire weather. That preserves the oxidant margin where it matters. At the surface, where heat and humidity push against our delivery, protect intact tropical and boreal stands with money and tenure that land in the right villages. Fragmentation makes heat, mosaics reduce it. Restoration isn't just trees, it's water. Re-wet drained peat so it stops smoldering for months. Bring beaver back to headwaters and let ponds lift humidity locally, shaving fire risk. Pyroecology is the nerve system. Good fire under cool weather reduces bad fire when heat arrives. Tribes and crews that know how to burn early are cheaper than fleets of aircraft in August. Urban canopy counts too. Target the hottest neighborhoods, shade schools, and bus stops. A cooler boundary layer lowers the oxygen tax on brains and burners alike. Rocks set the long clock. You can't flip subduction, but you can steer the surface chemistry that interacts with it. Weathering of fresh silicates pulls CO2 out of the air, and over time eases the global oxidant demand by cooling climate. Dams trap sediment that should be burying carbon on deltas. Let some rivers carry their load into places where burial is stable. Floodplain reconnection spreads fines and locks organics without hypoxia spikes downstream. Industry is the sharp tool here. Steel with hydrogen reduction, electric arc furnaces for scrap, cement with lower clinker, calcined clays, and carbon-cured concretes that mineralize CO2. Each step cuts reduced gas emissions that otherwise spend oxygen in the atmosphere or ocean later. Mining tailings are a hidden ally. Ultramorphic waste rock can mineralize carbon fast. Design piles to breathe, then monitor the chemistry and let rocks do the slow, honest work. Fire is the lever we pretend we own and the lever that owns us. Fossil combustion is the most direct oxygen withdrawal we control. Electrify end uses, heat pumps for buildings, induction for kitchens, EVs for fleets, and you retire millions of tiny contracts with oxygen. Where flames stay, make them stingy. Tune industrial burners with live oxygen and humidity sensors. Stage air to keep radicals fed without CO and NOx spikes. Maintain igniters so starts are crisp. Safety depends on oxygen floors too. Inert tanks and silos to prove in limiting oxygen concentrations across temperatures and pressures. Don't trim margins to save weight and then hope. Aviation burns are a special case. Sustainable fuels must meet ignition and relight specs at the real corners. Hot, wet, mid-altitude. Certification knows this. Now run the matrices against the atmosphere we've got. Finally, manage wildland fire like a profession, not a panic. Cut fuels with cool season burns. Harden edges where suburbs meet brush. Ember-resistant roofs, cleared zones, backup water, smolder is the enemy of lungs and grids. Starve it in spring so you're not chasing it in August. The pattern is discipline. Oceans. Mix and stop feeding dead zones. Forests. Cool the boundary layer and burn smart. Rocks. Bury carbon where it stabilizes and clean the hardest chemistries. Fire. Retire what you can, sharpen what remains, and treat oxygen floors as engineering, not hope. Every lever moves edges back. Flames catch cleaner. Flights relight with less drama. Wards breathe easier. Bays stop going still at noon. You won't feel the permeg slope. You'll feel the work get lighter. The tipping timeline. Cascades, not crashes. Think steps, not cliffs. When oxygen budgets slip, the world doesn't gasp all at once. Systems miss quietly, then together. The danger isn't vacuum. It's cascades that feel like nothing, until they reorganize your summer, your job, your map. Near term looks like this. Coastal waters hit heat waves, while farm rivers run high with nutrients after spring storms. Stratification strengthens. Afternoon winds calm. Bottom waters drop below hard lines. Fish push shoreward, then belly-up piles appear in coves. A week later, a front mixes the layers and everything looks normal again, except the die-off, the smell, the closed beaches. On hillsides, marginal starts lean towards smolder, sooner in warm, humid, smoky air. Crews spend nights chasing stubborn edges instead of drawing clean lines. Power grids wobble as smoke and heat lift demand while gas turbines complain at relight. Backup generators in hospitals hitch once, twice, then catch. No headlines about oxygen. Lots of small notes about unusual conditions. Workplaces feel it in odd corners. A warehouse shifts breaks earlier because mistakes spike after lunch in July. A refinery retunes burner oxygen sensors because startup smoke trips monitors. An airline bulletin adds a line about relight technique on hot, humid cruise nights. These are micro-cascades, smaller effective oxidant, more heat and moisture, narrower margins across domains we assumed were independent. Midterm, steps get taller. Oxygen minimum zones expand laterally and upward, pinching fisheries against the coast or into thin bands where storms and predators compress them further. Catches swing, boats idle. Insurance prices volatility, harbors get quiet on blue sky days. Cities adapt to chronic heat and smoke. Ventilation and filtration become standard. Schools put CO2 and temperature on walls. Some districts shift start times to dodge afternoon fogginess. Hospitals grow their own oxygen with PSA units, size storage for longer emergencies, and hardened backup power, because summer outages now arrive with smoke and ER surges. Industrial furnaces add oxygen enrichment to keep quality steady, an admission that the contract changed. Aviation routing leans into changing jet streams. More fuel buys, fewer bumps. Sustainable fuel specs expand to validate ignition at hot, wet corners. Maintenance watches for hesitant light after humid climbs and patches with software and parts. Globally, the pattern isn't apocalypse. It's redesign. Utilities treat intake air like a variable, not an ambient given. Turbine houses add treatment for heat and haze. Fire seasons stretch. Prescribed burns fight for safe windows. Pyro crews get paid to prevent instead of chase. Buildings show their air on dashboards. Operators act when numbers drift. The oxygen meter keeps sliding by per meg. The fixes keep pace where attention lives. Long term, if we do nothing structural, stratification locks in. The ocean's deep breath slows. Anoxic zones spread into places that never saw them. Benthic communities simplify. Nutrient cycles reshape as organic matter sinks into low oxygen water and decomposes poorly. Forests shift poleward and upslope, where heat and drought outrun roots, dieback patches stitched together. Fire behaves like a new biome driver: more smolder, more smoke, more regional dilution that feeds back into combustion, cleanliness, and human performance. Industrial oxygen becomes a utility. Critical facilities size storage for weeks, not days. Construction treats indoor air like electricity: metered, managed, designed. Uncertainty runs through this. Model ensembles bracket outcomes. Ocean deoxygenation trends are robust, but pace depends on emissions and nutrient policy. Wildfire behavior depends on fuel mosaics we can change. Aviation margins depend on standards that already evolve. Some places will see relief fast when levers move. Coastal hypoxia responds within seasons to nutrient cuts. Building ventilation fixes classrooms in weeks. Burner control upgrades cut CO tomorrow. Others answer slow. Forest age structures, sediment burial, overturning circulation. The wrong lessons are fatalism and vibes. The right one is leverage. Cascades accelerate where stressors align. They slow where you break alignments. Cut fertilizer runoff and restore wetlands, and a river mouth that used to annualize fish kills breathes through summer. Restore cultural burning, cool boundary layers with canopy and water, and fire returns to maintenance instead of crisis. Electrify end uses and clean grids, and you retire 1 million tiny oxygen contracts. Modernize cement, steel, and shipping chemistry, and you trim reduced gas emissions that tax oxidant budgets. Put oxygen resilience into hospitals and data centers, and a smoky week is an inconvenience, not a failure. Meanwhile, watch thresholds. Define local oxygen floors, limiting oxygen concentration in a refinery tank. Relight envelopes for a fleet. Winter dissolved. Oxygen minima for a bay. Classroom CO2 and temperature targets that protect cognition. Track them publicly. When they creep, don't debate weather. Move a lever. Because the timeline won't hand you a single day to circle and call the end. It will hand you stair steps. If we sleepwalk, each step is a stumble. If we steer, each is a platform. Cascades are physics. Whether they crash or reorganize is on us. Fix or suffocate, the playbook that actually moves the needle. Gestures don't change chemistry. If we want air that keeps doing work, lighting clean, cooling lungs, feeding oceans, we need moves that hit budgets and delivery. 4 arenas, specific plays, measurable gains. Oceans first, because they respond fast when you stop hurting them. Warm lids trap oxygen near the surface. Nutrients feed blooms that rot and spend what's left below. The lever is delivery. Keep nitrogen and phosphorus out of rivers, so summer hypoxia doesn't bloom on cue. Buffer strips and cover crops slow runoff. Wetland reconnection denitrifies what slips through. Stormwater systems that don't mix sewage with rain keep heat waves from turning into oxygen crashes after every downpour. These are boring interventions that buy real oxygen within seasons. Pair that with mixing where it counts. Restore tidal exchange in choked estuaries, time freshwater releases to break stratification, and design living shorelines that baffle waves and stir. Offshore, treat ocean fertilization like surgery. The science is clear. Proceed only in small, monitored experiments, and only after you fix runoff, the low-hanging win. Forests are the bodyguard of oxygen delivery, not the bank. They cool and moisten boundary layers, raise cloud bases, and cut fire weather. Protect intact tropical and boreal stands, with enforcement and tenure that land money in the right villages, not press releases. Fragmentation makes heat. Mosaics reduce it. Restore with water in mind. Re-wet drained peat so it stops smoldering for months. Bring beaver back to headwaters to stitch ponds that lift local humidity and shave risk. Pyroecology is prevention, not panic. Pay tribes and crews to put good fire on the ground under cool weather. So bad fire has less to eat in August. Where suburbs meet brush, codes do more than slogans. Ember-resistant roofs, cleared zones, backup water systems that work when power flickers. Urban canopy is oxygen economics. Shade the hottest neighborhoods, cool schools, and bus stops, and you lower the oxygen tax on brains and burners. Rocks set the slow clock, but heavy industry is where we grab the dial. Weathering of fresh silicates pulls CO2 and eases pressure on oxidants over time. Help it. Reconnect floodplains so rivers spread fine sediments and bury organics where they stabilize. Stop starving deltas with overtrapping dams. In mines, design ultramafic tailings to breathe and mineralize carbon. Monitor pH, fluids, and fluxes. Then scale the sites that prove they lock CO2 safely. In steel, flip the chemistry. Direct reduced iron with green hydrogen, electric arc furnaces for scrap. In cement, cut clinker with calcined clays and limestone cements. Cure with CO2 to mineralize carbon into the product. These aren't lab toys. They exist. They cut reduced gas emissions that would otherwise spend oxygen later, and they anchor procurement. Governments can move markets with standards. Buy low-carbon steel, cement, and asphalt. Publish EPDs. Let bids reward real chemistry. Fire, the lever we touch most directly, demands triage. Retire unnecessary flames. Electrify end uses. Heat pumps instead of fossil furnaces. Induction instead of gas. EVs and e-buses where duty cycles fit. Every retired burner cancels a tiny oxygen contract and a plume of NOx, CO, and soot that dulls lungs and flames. Where combustion stays, sharpen it. Industrial burners need live oxygen and humidity sensing, with staged air to keep radicals fed cleanly. Maintain igniters so starts are crisp, keep CO and NOx monitors honest. Inerting isn't a suggestion. Hold tanks and silos below proven limiting oxygen concentrations across temperatures and pressures. Aviation sits on the tightest margins. Sustainable fuels must demonstrate ignition and relight at hot, wet corners, not just cold, dry pages. Certification knows this. Now test where the atmosphere actually lives. Turbine makers should integrate real-time humidity and temperature into relight logic. Operators should practice flameouts in the new corners and feed maintenance squawks about hesitant light back into software and parts. Hospitals and data centers treat oxygen as infrastructure. On-site PSA plants backstop deliveries. Bulk storage is right-sized for smoke seasons. Manifold rooms are cooled and filtered. Layered backup power, batteries plus engines, keeps oxygen plants online when grids hiccup. Drill rationing protocols not for drama, but for comfort. Boring, repeatable, survivable. Schools and offices get dashboards that matter. Put CO2 and temperature on the wall, color-coded to actions. Purge, open, slow. Tie HVAC to multiple sensors per zone, so a stale corner doesn't ruin an afternoon. Tiny displays change behavior more than memos. Policy is the multiplier. Nutrient trading pays farmers to keep nitrogen out of water. Watershed compacts fund wetlands where they shave dead zones fastest. Building codes count air like they count egress. MERV 13 filtration and demand-controlled ventilation become standard. Procurement buys oxygen resilience. Discounts for hospitals with on-site oxygen. Points for utilities that harden intake air. Airworthiness standards expand relight maps to hot-wet regimes. Fuel specs include ignition behavior at those corners. Track receipts. Bays that shrink their dead zones after nutrient cuts. Schools with lower CO2 and better scores. Furnaces with lower CO and fewer false trips. Turbines that relight faster in humid air. AQL dashboards trending green in heat waves. These aren't vibes. They're the gauges that tell you the work got lighter. None of this is a crusade for purity. It's plumbing for thin margins. Cool the lid, stir the water, lower the load, sharpen the flame, and make oxygen supply boring where failure hurts. You won't feel the per meg slope. You will feel a match that catches, a bay that breathes, a ward that stays calm, a flight that lights on the first spark. That's the needle we can move. The big ledger, oxygen in the long cosmic fade. Pull back from our century and widen the ledger. Oxygen isn't just the gas in your next breath. It's a currency minted in stars, banked in rocks, traded by oceans, and budgeted by life. In the bright ages, free energy is everywhere. Hot stars, cold space, steep gradients. Oxygen is how complex things cash those gradients into work. But every engine closes its tab. The far future is a slow audit. Start where oxygen begins. Massive stars fuse and die, forging oxygen and throwing it into space. Planets inherit it as silicates and oxides. Water carries it as a solvent and a memory. Life learns the trick of photosynthesis and splits water, stacking O2 into the sky. The atmosphere we enjoy is not a gift. It's a balance between burial and spending. Bury organic carbon and reduce sulfur, and O2 can rise. Vent reduced gases and oxidize buried carbon, and O2 falls. That seesaw made our eras. Now, roll the clock forward. Star formation crests and slides. Galaxies drift apart faster, the easy gradients thin. Red dwarfs take over, frugal suns with trillion-year patience, while white dwarfs and neutron stars multiply like cinders. The oxygen economy shifts from growth to maintenance. Oceans still trade O2 across thin skins. Forests still cool boundary layers and set clouds. Microbes still shuffle electrons in the dark. But it's thrift, not abundance. Strip the story down to rules. Oxygen only does work because temperature and chemical differences exist. As the universe ages, differences flatten. Heat spreads, metals settle. The big account's close. If protons decay, a possibility at time scales beyond any textbook, rocks and organics unmake themselves molecule by molecule, erasing stores that once kept O2 tallied. If protons don't decay, those stores linger, but nothing drives them hard. Either way, engines that needed steep gradients fade. Black holes hold the strangest ledger. They swallow the history, stars, gas, perhaps future archives, and pay it back as a whisper called Hawking radiation on a timeline that makes geologic time feel rash. Stellar mass holes evaporate on 10 2067-year clocks. The giants at galaxy centers take beyond 10 to the power of 99 years. By then, oxygen as a breath or a flame is a story told at a different scale. What remains are photons, neutrinos, and a scatter of stubborn particles drifting in near equilibrium. Why does this cosmic fade matter to our oxygen fraud? Because it sets the context. Oxygen is a success story of differences exploited wisely. Our age is loud because Earth still has big gradients. Cold depths, warm sun, fresh rock, mixing oceans. We can still stack O2 in the air by burying reduced stuff and cutting dumb flames. We can still move it to where it buys clarity, lungs, bays, burners, by stirring and cooling. The ledger says that doesn't last by default. It lasts because someone keeps the books honest. So the long view gives two instructions. First, spend well while gradients are generous. Protect the feedbacks that keep O2 available. Burial where it stabilizes, cool boundaries that lower demand, flows that deliver. Second, stop adding new debts. Fossil flames don't just raise CO2, they draft oxygen for no good reason in a century that can run on electrons. In the far future, oxygen's meaning drifts toward mineral chemistry and faint memory. In our moment, it still lights a match, carries a ward, and keeps a cockpit bright at 3 in the morning. There's humility in this. Oxygen is not a moral, it's math. But there's purpose too. In a universe trending toward quiet, the brief ages that can arrange energy into thought are rare. Oxygen made that trick easy here. The fraud isn't that air is lying, it's that we act like the account can't run short at the edges. The rock record says it can. The meters say it's drifting. The fixed list says it's manageable if we stop pretending the ledger doesn't exist. So we honor oxygen by doing what made it abundant in the first place. Bury the reduced, quiet the unnecessary flames, cool the lids, mix the waters, and move precision to the edges where failure hurts. That's not saving the cosmos. It's buying time for the only chapter we can write. Air is a budget, not a backdrop. Guard the gradients, and oxygen keeps buying light, clarity, and work where it counts. If you want the levers that move margins, oceans, forests, rocks, and fire, stay with us. Subscribe for more true science stories, and watch the next deep dive on Earth's hidden plumbing that keeps your next breath paid for.